So before we move on, I want to run through one more example set. We're going to switch databases to the Northwind database. This is the ERD for that database. So you can see that it's just a company with suppliers and products and orders, employees, customers, shippers. We're going to focus on the employees and customers tables and see what we have to do to answer a few different questions that we might pose with this data. Okay, so we're going to keep this in mind that we have the employee table, we have the customer table with an associative entity in the middle of that. Okay, so the question that we're going to start off with is which employees helped with which customers? So to answer this, this is going to be the statement that we use here. So we have the first name and last name of the employee, and we have the company name for the customers. From the from table, I've aliased these as E, O, and C. Notice that the orders is slipped in there, even though we're not pulling the orders. Like there's no attributes from the orders in there. Why does that need to happen? Because it has to travel through the associative entity, basically. So if you look at, if we go back over here, the employee ID can't be on the customers table, and the customer ID can't be on the employee table. They're both connected in on the orders. So we need to say where the employee ID equals the employee ID and the customer ID equals the customer ID. And that's exactly what we have here. So we need to call up all three tables here, and we need to make those connections. So the number of connections you have here in the wheres for the keys is going to be one less the number of tables that you have. Okay, so if we run this, what happens? We get every instance that an employee helped out a customer. Notice a few things here. We have some repeats. So Janet helped around the horn a few times. So did Nancy. We got 3 instances of Nancy doing this. Total, we have 830 in this output. That's definitely not what we want. This is basically every single order. How do we fix this? How do we get a smaller list so we know which employees have actually helped out each business? We're going to add in our distinct, which basically gives us unique entries, no duplicate rows. Oops. Distinct spelling matters. Okay. So it looks a little scary because it reordered it. Because remember, the distinct function not only is going to make the unique thing happen, but it also orders it. In this case, it ordered it by the first name, starting off here. It would have ordered like in order like that. But you can see that there's only 464 rows in our output. So cut it down by like half. And now we don't have any duplicates. Huzzah! We win. We win SQL. Okay. So that's interesting information. What if instead we wanted to know how many customers each employee helped? This might be more useful information. So instead of a list of each one, we just want the totals of that. What does that mean? That means that we actually want to get, we want to add the aggregate function of count here. Count. Like that. And what happens whenever we have an aggregate function and we have some that are non-aggregates? We need the group by, which we just learned about. Group by with a space. And I'm just going to copy these two and drop them here. Okay. Well, what's that going to give us? Cool. Right? So much better. So we have Andrew Fuller helped out 96 people. How can we make this better? Fix this nonsense. Expression stuff. So we're going to do as count of customers, caps lock. Great. Love caps lock. Not really. Count of customers. There we go. We run that. Oh, we got a pretty name up there now. So lovely. Okay. But what if we had a lot of employees and we actually wanted to see who were our top salespeople and who's not so good? All right, so we would want to order this. So order by. If you're doing it by an aggregate thing, you want to do the entire count function. That's easy to forget to do. So you need the count. You don't need the alias over here. You need the real one there. And then for this one, we want it descending. There we go. Margaret was our top salesperson. Far outpaced Anne and Stephen down here in the 40s. So there we go. That's a really good SQL statement. Actually, we have a number of different things in here. We've got aggregate functions, we've got the group by, we've got ordering, we've got multiple tables going on. We've got the distinct function in there. There's so many things going on. So that's a pretty legit SQL statement. It seems pretty simple, but it's these little simple pieces that put together that make something super powerful at the end.